Vertex form of a quadratic function. This is a topic, or this question belongs to this topic, vertex form of quadratic function. So describe, identify the vertex, axis of symmetry, maximum or minimum, domain, and the range of each function. So under A we have y is equal to 2 times x minus 2 squared plus 5. And B we have f of x is equal with minus x minus 1 squared plus 2. So first of all, to make sure in everything, what I did here, I plug in those information, those two equations in the Desmos, and I got these figures. For A, I have this here, and for B, I have this graph of the function. So now let's go here and let's find out all the information. The vertex here is here minus 2, but is a 2 and 5. 2 and 5. So 2 and 5. Because this is a h and this is k. And h is a 2 and k is 5. That's why I'm taking here. Axis of symmetry. Axis of symmetry, x is always equal with the h. With the h, but h is a 2. So this is a h. This is k. Is always equal with h, which is equal with 2. So maximum or minimum, whenever the factor here is a positive, or the leading coefficient, whenever the leading coefficient of quadratic function is a positive, or in this case the factor, stretching or compression vertical factor, is positive, the function is going to be a concave up. So this is a concave up and always has a minimum. And where is the minimum? It has a minimum. Minimum is, where is the vertex? And the vertex is 2 and 5. So here is the minimum. 2 and 5. The domain of the function, of quadratic function. The domain of the quadratic function is all real numbers. Always the quadratic function or quadratic function has the domain from minus infinity to infinity or all the real numbers. So the range is the range of the function is from the minimum from this point here to infinity. So it means that the range of the function is from 5 to infinity. I'm sorry, from 2 to infinity. Yeah, from 5 here to infinity. So the range is from k to infinity, and k is a 5, from 5 to infinity. So for the A, those are the information for the A. And now we go in for the B. For the B, what is the vertex? For the B, the vertex is this is the H, this is K. So H and K are 1 and 2. So 1 and 2. This is the vertex. Axis of symmetry. Axis of symmetry always is x is equal with the h, and in this case h is equal with 1. So this is axis of symmetry. But if we want to look visually, the axis of symmetry is the line, here, this line here that divide the graph of the quadratic function in two symmetrical sides. So x is equal with 1. This is the line that goes through the goes perpendicularly to the h. Whenever it is the point h, goes perpendicular and divides the graph of the function in two symmetrical sides. So x in this case in the b is equal with 1. Maximum or minimum, because the leading coefficient here is negative 1. You see here is negative 1, but it's invisible 1. is a negative 1, then the graph of the function is a concave down. So it always has a maximum. And the maximum is located. Where is the vertex? But just let me show here the picture. The maximum here is 1 and 2. Here is the maximum. So the maximum is wherever is the vertex, and here is the maximum, because this is a concave down. And because of this is a little this a frame, and it goes forever, so this goes forever down. So let's go up here, and the maximum is 1 and 2 whenever is the vertex. But in this case, whenever is the leading coefficient negative of the quadratic function, it means the graph of the function is the parabola is a concave down, therefore it has a maximum point 1 and 2. What is the range? Domain, I'm sorry. The domain is always to the quadratic function is from minus infinity to infinity. So this is the domain. And what is the range? And range here is a little bit different. But here is the range is from minus infinity to this point here, to the y, when y is equal with 2. So the range is from minus infinity to 2 here. So those are the key features of the quadratic function.